Hi everyone, this is for if you want a refresher on the lessons for this week or if you missed the Google Meet. I'm going to be working through each Desmos problem. All right, so last week we talked about Pythagorean Theorem. We're going to do two review problems before we get into the word problems that then we have to do the Pythagorean Theorem. So if you look at this first one, remember I've given you the formula a squared plus b squared equals c squared. A great way to figure out where things go. Remember, if I draw a line from the right angle, that's the hypotenuse. We label that as C. A is the side that goes up and down, it's the altitude, and B is the side that goes side to side, it's the base. So from here I can just substitute in. So A squared is 20, B, we don't know what it is, and C is 35. So from there, I can square my numbers. So I have 20 squared is 20 times 20, so I have 400. Can't do anything with B, so I'm just going to leave it alone. 35 squared is 1,225. Now I ask myself, can I add these two together? Well, I have a variable and a number, so no, I cannot. So in order to get B by itself, I need to subtract. This will cancel out. I'm left with B squared equals 1,225 minus 400 is 825. My last step, remember I need to take the square root. So B is going to be equal to 28.7. So that will be my final answer for that particular problem. We're going to do one more review. This time we are missing C. We're missing the hypotenuse. So remember, right across from the right angle, the diagonal is C, the hypotenuse. This will be A, this will be B. So A squared, I put in an 8 for A. B is going to be 10. Oop. So 8 squared, 8 times 8, 64. 10 squared, 10 times 10, 100, equals C squared. Can I add this time? Yes, I can. So 100 plus 64 is 164 equals C squared. Take the square root. C is equal to 12.8. All right, now we're going to get into the problems where there's a word problem and we need to create the equation for Pythagorean theorem. All right, so it says PTAP is constructing a zip line for their ROTC students. They need to determine what length of rope to use to carry their students safely to the ground. If the school is 60 foot tall and the zip line will be anchored in the ground 200 feet from the base of the building, how long must the rope be? So if you look at our diagram, we already drew a picture. You have the 60 feet going up and down, so that is going to be my A. I'm going to choose a different color here. Let's go red. All right. Going across my side to side, that's going to be my B. My right angle can be drawn right here in the between the building and the ground, and across from that is what we're missing. That's going to be C. So remember, we have A squared plus B squared equals C squared. So A we just said was 60, so I'm going to have 60 plus B is 200, and we don't know C. So 60 squared is 3,600. 200 squared is 40,000 equals C squared. Remember, you can use a calculator. Definitely when you're doing your square roots, you will need to use a calculator. All right, can I add these two together? Yes, I can. So I have 40,000 plus 33,600. It's going to be 43600. So 43,600. I take my square root. C is going to be equal to 208. So in order for it to have enough rope, they need to have 208 feet of rope, just a little over. All right, let's look at another one. So it says a weather balloon is launched from a site 5 kilometers away from the weather station. If the balloon rises straight up to a height of 8 kilometers, how far is the weather balloon from the weather station? So first thing, we should draw a diagram. So we're going to say that the station is right here, okay? Ooh. And the balloon was launched 5 kilometers away. So 5 kilometers away, this is where the balloon was launched. Once it was launched, it then went 8 kilometers up. So they're trying to figure out how far it is. Ooh, that's a terrible line. Let's draw an actual straight line. How far the balloon is from the weather station, okay? So here's where our right angle is going to be. So across from the right angle is always the letter C. A up and down, B side to side. So we can then substitute into our equation. So A, we said was 8 squared plus B, which is 5, equals C. So we can then do our math, and 8 times 8 is 64. 5 times 5 is 25. Can I add these together? Yes, I can. 64 plus 25 is 89. From there, I take my square root, and C is equal to 89. Square rooted is 9.43. So that means that the balloon is a little over 9 kilometers away from the station, about 9.5 almost. All right, let's look at number 5. So we have an 8-foot ladder leaning against a wall. The base of the ladder is 5 feet from the wall. How far up the wall will the ladder reach? So first I want to draw a diagram. So here's a building, here's the ground, here's the ladder. Okay, it says the ladder is leaning. So it's an 8-foot ladder. I'm going to pretend it's a ladder. Okay, it's 8 foot. All right, the base of the ladder is 5 feet from the wall. So from the end of the ladder to the wall is 5 feet. So we need to figure out how far up to here the ladder is. So this right now is missing. So here's my right angle. We know 8 is going to be C. We're going to label the one that goes up and down A. So A squared plus B squared, which is now 5, equals 8 squared. All right, now we can do our squares. A squared can't do anything with that yet. 5 squared, 5 times 5 is 25. 8 times 8 is 64. Can I add? No, I cannot because I have a variable, but I can subtract. So I'm left with A squared equals 64 minus 25, 39. I can take the square root, take the square root. A is then equal to 624. That looks kind of like a 9, sorry guys. All right, so that is the height of the wall. That's where the ladder will reach. All right, let's look at number 6. So Megan had let out 50 meters of kite string when she noticed the kite appeared to be directly over Kathleen. So here's Kathleen, and here is going to be the kite. All right, so it's directly over Kathleen. Megan and Kathleen are 40 meters from each other. So let's put Megan here, and right here between them is going to be 40. We're not sure how far up the kite is above Kathleen, but we know there's 50 meters of string. Oh, that looks like 56. Let's change it to 50. Okay, so between the angle of where Kathleen and Megan are, and Kathleen to the kite is where your 90-degree angle is. So across from that is the 50. So the 50 is going to be the C. We have B because that goes side to side, so we're missing A for the height or the altitude. So A squared plus B squared equals C squared. A squared, we don't know. B squared can be changed to 40 squared. And C squared is going to be 50 squared. So A squared can't do anything with it, so I'm just going to stay A squared. 40 squared, 40 times 40 is 1,600. 50 squared, 50 times 50 is 2,500. I ask myself, can I add these two? No, I cannot. So I have to do what? I have to subtract. So I'm going to subtract from both sides. These cancel out. I'm left with a squared equals 900. I'm going to take the square root of 900. I'm going to be left with a equals 30. So the kite is 30 meters above Kathleen. All right, let's look at number 7. All right, Lisa and Rhonda are training to run a marathon. They ran 4 miles east and then let's do 4 miles east and 6 miles north. Okay, so 4 miles east, 6 north. If they could run a straight line back, we want to find that distance because it's going to be shorter than running the 10 miles that they just ran a second ago. All right, so here's my right angle. Across from that is C, the hypotenuse. So we are missing C in this case. A is going to be 6, B is going to be 4. A squared is 6 squared plus B we said was 4 squared equals C squared. 6 times 6 is 36. 4 times 4 is 16 equals C squared. All right, from there, I ask myself, can I add these together? Yes, I can. 36 plus 16 is 52 equals C squared. I can take the square root. C is going to be equal to 721. So instead of running 10 miles to get back to where they started, they could run a little over 7 to get back to where they started. It's a little bit shorter. All right, and number 8. In a wiffle ball game, the catcher throws to second base. So second base is over here. Okay, his first base is here, and third base would be over here. I'll change this to a 2. Okay. If the bases are spaced 30 feet apart, so from home plate to first base is going to be 40. From first to second is going to be 40. Second to third is 40. Third to back to home plate is 40. How far did he throw the ball? Okay, so we're looking for this right here from catcher to second. Now, our triangle's a little sideways. Here's going to be my right angle. You could also use this one by third base as well, it doesn't matter. Across from it is going to be my C. So because the numbers are the same, you both have 40 and 40, it doesn't matter the order. So we're just going to have 40 squared plus 40 squared equals C squared. Well, 40 times 40 is 1,600 plus 1,600 equals C squared. So that, I asked myself, can I add this together? Yes, I can. 3,200 equals C squared. I take my square root. C is equal to 5657. Okay, so that is the length from the home plate all the way to second base. All right, last problem. We have a gym at Coolsville Middle School, and it's a large rectangle. So let's draw a rectangle. All right, for a game, the gym needs to be split diagonally. All right, so here's the diagonal. If the length of the gym is 30, and the width of the gym is 12, how much tape will be needed to mark the diagonal? All right, well, I'm going to take this right here, make that my right angle. Across from the right angle is C. A is going to be the up and down, B is going to be the side to side. So A squared is going to be 12, B squared is 30, equals C squared. 12 squared is 144. 30 squared, 30 times 30 is 900, equals c squared. Can I add together? Yes, I can. 900 plus 144 is 1044. I then take the square root. C is equal to 32.3. So that is how much tape I would need. So 32 1/3 yards of tape for the diagonal of the gym. Okay, and that is it for this week's lesson number 1 for real world Pythagorean theorem problems.